Yes, and share my screen. Yes. Can you see my screen?
Yes.
Yes. Yeah. Okay. So today we'll be talking about project authorizations, past, present challenges, and the future of project authorization. So my name is Manoj. I am a backend engineer at the Talent Skill Group, but previously I used to be in Manage Auth and Manage Organize. And during my time in Manage Auth, I used to work a lot in project authorization. So that is how I know most of this stuff. So let's get going. So the first part is a very basic introduction to project authorizations and what it is about. So project authorizations is basically a cache for storing the access level that every user has to the projects that they have access to. So it's a very simple table consisting of three columns: user ID, project ID, and access level, where you store the specific data. So I have put a question mark in front of cache because I don't know if we can really call this a cache, in the sense that in cache systems, what happens is if the cache is missing, we call it a cache miss. We are able to obtain the right value from making that calculation without the cache also. So if there's a cache miss, you go directly into the source and figure out the value. But in this case, that's not really happening, because the expectation that the system runs on is the fact that the value of access level is present in the other project authorizations table. So if there is a cache miss, then the whole system goes for a toss. So cache is probably not the right term for it in the right sense. Maybe we can call it something as a pre-computed value. But for simplicity's sake, we can assume it to be a cache. But we can always rebuild the cache. There are systems for it. But if there is a cache miss, then system goes for a toss, which means that somebody does not get access to the project. So yeah, so that's the basic detail. And here I have an example of like what it looks like in our app. So this is a Rails console where I have fetched all project authorizations. So you can see like user IDs differ, projects differ, and access level differ, and there are values of access levels here. And there is a uniqueness scope on user ID, project ID, access level combination. Okay. Yeah, okay. Yes. So yeah, there is a uniqueness scope on user ID, project ID, access level combinations, which means that a specific user can have only one kind of access level to a project, which means that you can be a maintainer in one project, but you cannot also be a owner of that project. So it's always unique that way. So that is one of the constraints we have on the table. Next slide. Okay, so this has been bothering me. Okay. Yeah. Yes. So the questions that can come up at this point is why do we use project authorizations? And the reason is we use it as a cache because we want the pre-computed value to be always there. Otherwise, fetching it from the members table, like you add a member, add somebody as a member to a project. And if you compute via that members table, then it takes a lot of time because that computation is hard, it's expensive. So what we do is we already pre-compute that value that a specific person has to a project, and we store it in the project authorizations table. So that is why we have project authorizations. And the corresponding question is, why don't we have group authorizations? Because users also have access to groups, and we don't have a table called group authorizations. And if computation is hard or expensive, why don't we have group authorizations table? So the reason to that is we kind of have satisfactory performance on the group side of things, but we did not have satisfactory performance on the project or project side of things. Because when you do a git push to a private repo, you want it to be as instantaneous as possible. And we do not have time there to go into members table and check whether, hey, does this user have enough rights to push to this repo. So on the group side, there are also, so if you can imagine as a tree, a group is at the top level and project is at the leaf level. So once you traverse to the leaf, there are already like more components involved in the calculation process. So that makes it more expensive. But group is at the top, so you can imagine that it's easier to figure out the value at the top level. So that is why we don't have a group authorizations table yet, but it might come at some point. Currently, we do not bother because the performance is kind of satisfactory. And it's also hard to maintain a cache. So that is also one of the reasons we don't want to go there unless it's absolutely necessary. Next slide. So there are some existing concerns around project authorizations before we dive deep into it. So the first point is this cache can be considered wasteful because we have to store every user's pre-computed value to every project that they're part of. For example, on my day-to-day job, I only use the GitLab Rails project. But then since I am part of the GitLab org group, I am part of like thousands of projects underneath it. And my access level to each of these projects is stored in the project authorization table, even though I like virtually never access those projects. Like in my day job, I maybe go to the handbook repo and also the GitLab Rails repo. These are like the two projects that I use, but I have entries for all the other 1,000 projects, which is kind of, in a sense, it is wasteful. And the second point is, like I told, this is a pre-computed value, not really a cache. So it is a cache that only grows. Like the value will never decrease unless there are like the user is deleted or something, the project is deleted. So you can imagine that the size of this table is only going to keep growing as GitLab grows. Next part is maintaining any cache is hard, but maintaining the cache of project authorizations is doubly hard because any problem that you have in this table, it is a severity 1 issue, which means that like if the access levels differ, then somebody is going to get elevated access or somebody is not going to get the proper access. So all of this, which is can be considered a severity 1 issue. So we have to be very careful while dealing with project authorizations. Any questions this far? Okay.
I do. I have one.
Yes. Okay.
So does the whole concept of customizable roles, after all, since this is about storing roles and access, does it make it even more complicated now?
Yeah, if I understand correctly, so I was not part of custom roles, but if I understand correctly, we do not store the custom role in this table and it is calculated on top of that. So definitely it makes it more expensive. So you have to find that this person is a maintainer, it will have an access level of 40, but it may have some owner rights, so that is calculated differently.
And this is also the exact reason for why we had first the technical discovery on customizable roles, because we were very concerned of this very issue that this might be this might have very poor performance.
Okay, makes sense. So what you ended up doing at a high level is decoupling the two?
So not entirely decoupling. We still have on customizable roles, we have the base access level. So that's reflected on this. What we try to do is to move away from relying on project authorization on these specific permissions and rely on these on-the-fly calculations, so we can check if the user has the custom permission that they need, but that needed to be very performant.
Okay, thank you.
It's more like one on top of the other, so the existing system continues, but we also check whether this has any custom roles and calculate that also.
Okay.
Yeah. So we have this cache, but we need to keep it updated. Otherwise, like I told you, people don't get the proper access to the projects. So the next question is, when do we update this cache? And updation happens whenever we trigger an action that needs to update the project authorization state, which means that like when you add a member to a group or a project, when you delete a member from a group or a project, when you transfer a group, the hierarchy changes. So in that case, you also have to update. So all these actions that happen, which warrants a change to your project authorizations, is when we trigger this updation. And to update these project authorizations, we use workers, which are like sidekick workers. They do it asynchronously behind the scenes, so it does not wait on the requests. And the worker that we use for it is called the authorized projects worker. And authorized projects worker always refreshes authorizations on a per user basis. By per user, I mean that simply means that the argument that goes into the worker to perform the job is the user ID of the person. So in this case, whether as an example, when a user with ID 42 is added to a new project or a group, we would usually run authorized projects worker dot perform async 42, and that will do the calculations, figure out if the user term named 42 has need to have access to any new projects, or has this person lost access to any project, and we remove and add project authorization records, that those rows in that specific table as necessary. So that is what we are used to, and we kind of now call the system as the legacy system because we have something new to do this. So when you say the legacy worker, you can imagine it is actually the authorized projects worker that we are talking about. And we had many challenges around authorized projects worker. The main challenge being, I told you, this works on a per user basis, and per user basis is very expensive calculation. And it is also not really necessary to do stuff on a per user basis. As an example, when a new user is added to a project, you do not need to fetch data surrounding this user's access to all other projects. So if I'm added to the GitLab project, essentially I need to figure out, I need to add an entry for Manoj with access level of 40 to the GitLab project. But then what happens inside this worker is it fetches all of my existing project authorization records also. So that is a very expensive calculation that is happening. And that was the major challenge because the time required to do this is very is kind of high. And when you have so many jobs in the queue that does this, you have infrastructure challenges that we couldn't meet SLOs on certain days. So the worker that runs this is doing a recursive query because we have like our hierarchy is such, like we have groups and then projects and subgroups and then projects inside that. So it used to do like a recursive query, but in May 2023, we have kind of changed it to linear queries. I think Abu Bakr worked on it. I still don't know if the feature flag is turned on, but there have been we have been moving in that direction, which kind of removes the expensive part. It's not recursive, but now it is linear based on linear queries. So it should improve the performance a bit. Next, yeah, so I told you this is kind of the legacy worker now, which means that we have something new in place of that. So around mid 2020 is when we started having infra dev issues around project authorization. We used to have like a lot of problems, and that is when we decided to like think about alternative solutions, with something that can improve performance and not have so many infra dev issues coming our way. And the alternative that we talked about or we came up with is called a scoped worker, which would be much more performant. And let's look at scoped workers. So so the scoped worker we have right now is called a project recalculate worker. And scoped worker simply means that it works on a specific. I'm very sorry. This is happening right between the call. Okay. Yeah. So this does refreshes on a per project basis. If you remember, the last one did refreshes on a per user basis. So this does it on a per project basis. So when, for example, when a project with ID 40 is transferred from one group to the other, we simply do project recalculator worker dot perform async 40, where 40 is the project ID. So inside this job, what happens is it is able to fetch all the members arising from all different areas, like from within the group, the ancestors, direct members of the project, people from project group links, it is able to fetch all of them together and figure out how like all of the users that have access to this particular project. So that is what we mean by it does the work on a per project basis. Yeah, so this is the diagramized diagram of the case that I was trying to tell you. So project P is moved from group A to group B, and now it is part of project P. So you can imagine that there are users in group A and users in group B. So now previously users in group A had access. Now they will lose access and people in group B should get access. So earlier what used to happen is we used to like take a union of all user IDs in group A and group B and run the legacy worker for all those users, which means that there are multiple jobs being happening for all those users. If there were like 100 users combined in both groups, this was like 100 different jobs, and people in group A will lose access, people in group B will gain access. But now this is much simpler. This is just one job. We just simply pass the project ID of that project, and it is able to figure all this out inside one single job. So when we deployed it, we had like a really good improvement in all metrics that we calculated, like close to 99% improvement everywhere in number of jobs being generated, because this is like n jobs versus one job, and also the time spent in DB and the number of queries that were fired. So yeah, close to 99% improvement in efficiency there. Any questions? No. Okay. Yeah. So so everything was not really nice, as the last slide showed you. When we started getting good results with the new worker, we thought like, why not apply the same thing everywhere, and we would have better results everywhere. So that is when our problem started. So after we saw this approach, we wanted to try this everywhere. And to do this, we started shipping Project Recalculator Worker even on group membership updates, which means that when you add somebody to the group, every project under that group should have a new project authorization for this person, which means that if a group has 100 projects under them, this would mean that we are giving rise to 100 different project recalculate worker jobs. But we thought that since the performance of this worker is far better than the legacy worker, it should be okay. And we shipped this change, and this led to an incident. And the lead, what happened during the incident is the QA test started failing. And on checking that, we came to know that like too many jobs were waiting in the queue, and the queue depth was increasing. It was higher than usual. And we realized that it is because of the changes we deployed for group member updates. In simple terms, what went wrong is this is a case of frequent action giving rise to n jobs in one go, wherein it's a very large number. So adding member to a group is if you consider GitLab.com, that's a very frequent action. And when you add members over API, that happens very successively, and each of them is triggering like 1,000 jobs or more. Every job is in the queue, and then the queue gets clogged. So that is what happened in this case. And yeah, so this gave to like many project recalculator worker jobs, and it happened very like one after the other, because we have no control over how customers use the API. So they can add like 1,000 different members to each group that they want. So this is the case that happened. And the takeaways that we have from this incident is never have like n refresh jobs being generated from one action. But if you have like a one refresh job generated for one action, that is kind of correct. So the takeaway here is, when using scoped workers, use them for the right scope. What happened with us is, where we went wrong is, we had a project scoped worker, but then we started using it for an action that takes place in the scope of a group. So that should not happen. We should scope it correctly and also use it for the right scope. So we reverted that change, and currently what we have is a hybrid approach of the legacy worker and the new worker. And on the left, you have the new worker, and that is scoped to a project. So we only use it in areas where the change happens directly on that project. Say, for example, when a user is added to a project, when a project is transferred, and stuff like that. So yeah, directly, it should affect directly on the scope. And on the right side, you can see the legacy worker. We use it, still use it, but we use it for cases where a group is affected, where like a group is transferred, or when a user is added or removed from a group. So we continue using a combination of both right now. Yeah, and regarding the future, there are like two different areas that we want to focus on. One is we have a proposal for groups for scoped worker. We do not have it currently, and that can solve a lot of problems. And hopefully, if that happens, we might be able to retire the legacy worker. And we can use group scoped workers in areas where the legacy worker is currently being used, like adding a member to a group, removing group transfer, all of that stuff. And we also want to remove safety net workers from across the code base. This is so in GitLab.com, the safety net workers run on the replica, so there isn't much damage being done that way. But on self-managed instances, these safety net jobs runs on the primary, and for such installations, it might be a problem. So we want to remove the safety net jobs at some point, but before that, we have to make sure that our new workers give us the right output. We haven't been able to measure that, but once we measure it, and if the results are right, we can also remove the safety net workers from the code base. And this is the like how safety net jobs function. So the first line, this line is the new worker, of course, and the second line is we want to until we compare the consistency rates, we just enqueue also the job in the legacy worker, but with a low priority and with a 1 hour delay. So we want to remove it at some point. Yeah. So yeah, that's about it based on project authorizations. If you have any questions, I will be happy to answer them. I think we have questions on the doc, but if you have any more questions, you can add them here. Yeah. Maybe we can stop sharing the screen. Yeah, is everything clear? Do you have any part that I can explain more?
I have one question.
Yeah.
So you described the incident
Yes.
where the queue was clogged with a bunch of jobs. I wonder what happens if, so let's consider the project recalculate worker. So let's see that let's assume that the queue is already clogged and the member is added to a project. So there's a new job is created to recalculate the authorization for the project. And then something else happens to the same project, and then other job is added to the queue for the same project. Or so could that happen, that there are like hundreds or thousands of jobs for the very same project to recalculate?
Yeah, that can happen, but the good thing with the new worker is the deduplication key is the project ID. So in that case, the jobs will be deduplicated. But in the other case, the deduplication key was the user ID, because so if you add different users to the same group, each job is unique because the key is user ID. So it is never deduplicated. Does that answer your question?
Yeah, thanks.
Yeah.
What is the, you've talked a lot about these jobs getting stuck in the queue.
Yeah.
Does that actually like, what does it bring down GitLab, or is it just a case of maybe you don't have access to the project you should? What is like the user-facing impact of it?
So it's a mix of both, I would say. There are also other jobs waiting. So when you wait, the access policies are not applied correctly, so you lose access. And on the higher level as a whole, also our Sidekick systems come to a stop because there are also other jobs happening in other parts of the code base that needs to use Sidekick, and since it is clogged at this particular point, they also cannot process, and it's sort of leads to a cascading effect. And yeah. Maybe we can talk about what Jesse has also asked in brief. Yeah, so Jesse has asked whether the async nature of project authorization worker has ever caused any problems, and I have replied that async means that it happens behind the scenes, which means that you add a member to a group and they do not get this access instantly, like it is near instant, because it has to go in the background and process it. So we have no control over when that job finishes. For example, if they are stuck in a queue, it may finish like after 1 minute or so. So this was always not the case. We did not have async refreshes from the beginning. It used to be sync refreshes, which means that as soon as you finish the request, you also had access to the project. But at some point we had to change that because it is not always nice to wait on request. It will increase the response time, and it will also skew your metrics for the error budgets and stuff like that. And we also had another reason to do like async everywhere. So we shifted to async mode, but we are also aware of the fact that the access levels are not instant. It is near instant, and we had to take that call. We are okay with having near instant access. It might change after a few seconds or 1 minute or so, but we also make sure that these queues are considered high priority by GitLab.com Sidekick fleet. So it tries to finish it off as soon as possible, but it is not guaranteed to be instant. Right. Yeah. I think that's it. Any of you have more questions?
So you're on tenant scale now. So how is the concept of organization and everything you're working on there, how is that factoring into this?
To be honest, we haven't reached a stage where we have started to think about project authorizations yet, because projects will still exist, users will still exist. So we are confident that some version of the table will continue to exist. But I think we were also talking about whether group authorizations need to happen, because now organizations will have groups, and it might be much easier to pre-compute that value and store it somewhere rather than figuring it out on the go. So that might happen, I guess, but we haven't reached a stage where we could like have a concrete plan about what to do with project authorization.
Okay.
A related question to that. So there's also the group project consolidation effort, and I was wondering if you mentioned the group authorization table that you are considering. Would it make sense to just create a namespace authorization and use that for both project and group instead of treating the two as two different entities, or are there benefits to keep them as separate entities?
So what I think about it is there are like variations in projects and groups on how we get memberships, because there are group shares, but there are no project shares. So variations exist that way. So even if you make it like namespace ID, access level, user ID, internally we will have to differentiate somewhere between a group and a project, and then fetch members of them and do the whole thing. So the if else condition in that case would appear somewhere, but yeah, having it as namespace would make sense, because then you can contain it in one single table. Otherwise you would have to like split it into project authorizations or group authorizations. Yes, there are no more questions. I can stop the recording. Okay.
There's no more questions. I'll just make a general comment that you did an excellent job breaking this down to the point where even I could follow along. So
Okay.
Great job. I think that was, it takes a lot to take something like this and make it easily consumable. So nice job there.
Okay, thank you.
Yeah, and I think it's very, very useful, this summary and the presentation you provided, because there's like a lot of detail and historical context to project authorization. And this was like a very, very nice summary.
Yeah, I always think about the fact that somebody in the group should be acting as the historian of manage auth, because there is a lot of there's a lot of context. I think at this point I think it is Imre, but somebody needs to be there, because it is very easy to lose context. There are a lot of historical context around like what considerations we did to reach this point. So yeah.